All right. So let's take a look at a couple things about it. Quick comment. Again, we're looking at small p-values. Right? Small p-values go with the large chi-squared values, and that's what we consider unusual. Right? When we're a small p-value, that's when we reject H. So let's go ahead and let you folks try one. Lab problem 2, or actually, sorry, lab problem 8. So go ahead and give it a shot. Sports preference. So their claim is that there is a difference, right? Which means that it is dependent. That means that it is related. So those kind of are the three things you can kind of look at. That's their claim, difference. So if it's different, that means it's not equal. So that'd be the H1, which again would go with relationship or dependent, not equal to. And then also don't forget, you always want to find the expected value for the first and the last in the matrix. And I highly recommend putting brackets around your matrix. So figure out where your data ends. Do not include the date and the totals, and then you'd find the expected value for the first one in the matrix and the last one in the matrix. Upper right corner, upper left corner, and the bottom right corner. All right. So step 1. We're going to take a look at our H naught H1. H naught is the sports preference is independent of gender. Or you could just have said O sub I equals E sub I. Or you could have said, what, not related? Is that what some people said? Or no difference between?
Not equal.
Not equal.
Oh, so H naught should be equal.
Right.
So
H1.
oh, H1, I see.
Yeah.
So H1, so you folks must have did O sub I equals E sub I?
Yeah.
Okay. Yep, or you could have done H1 is O sub I is not equal to E sub I. Or you could have said is related. Independent or dependent, right, related, all those are fine. And again, this is the claim. So we're going to use support later on. Good. Step 2, alpha is 0.05 because it wasn't given.
Yeah.
All right, so next you folks found your E11, and again, I recommend you box it out like that. So it's going to be E1, comma 1, and you all did 32 times 38 over 80, and got 15.2, I think is what people got.
Yes.
And then the last one is this 12, what row is it in?
2.
The second row, what column is it in? 3. So it's going to be E of 2 for the second row, comma 3 for the third column. So that's going to be its row total 48 times its column total 16 over 80, and y'all got 9.6 for that. Then you did chi-squared test of matrix A, and you got a chi-squared of 2.385 and a p-value of, oh yeah,
3034.
34, yep. Yeah, a chi-squared of 2.38, that's not very big at all. That's fairly close to 0. And the p-value is huge, so not surprisingly, your p-value is much bigger than alpha. So we're going to not reject or fail to reject H naught. Which means that there is not enough evidence to support the claim that sports preference is related to gender. I would have to have something like that, yeah? Okay. Homogeneity of proportions. Again, that's homogeneity just means the same. Proportions are the same. Is the exact same test. The only difference is the wording in claim might be that the proportions are the same or something like that. Here's your example. You see these proportions are equal or not equal. So go ahead and work on these ones. The same steps. You still have to find the first and last expected value. Don't forget that. All right, so let's take a look. What is our step one? Oh, let me go ahead and put the brackets around here. That's always good. All right, so step one, how about Austin, what's your step one?
Would it be like O on O like subscript I?
Yes, O subscript I.
Equals E subscript I, and then
Yep.
and then H1 isn't it always like O subscript I is not equal to E subscript I?
Correct. Okay, which one is the claim?
H naught.
Claim that there's no difference. No difference is what?
H naught.
It's not. So we're going to use what word in step 5?
Object.
Great. Step 2. Connor.
Alpha is not listed, or alpha is listed at 0.05.
Great. Step 3. Sean.
Well, first just do the matrix and set it all up, but it's chi-square test, matrix A, matrix B.
Yep. A. What did you get for your p-value?
I got 0.0027.
And your chi-squared?
I don't think I wrote it. It was 14.14.
Is that right?
14.15.
1.5. 1.5.
Or 1.5, yeah.
Okay, great. Now, also part of step 3, you need to give me your first and last expected values. If you don't give me your first and last expected values, you'll lose a few points on that. So, Arak, what's your first and last expected value?
36.
E what?
Oh, E1, comma 1.
1 comma 1. So,
100 times 144 divided by 400.
and you said that one was 36. And then what's the other one?
E2, comma 4.
Great. You guys see that? Row 2, comma, column 4. 2, comma 4. Okay.
And, 100 times 256 divided by 400.
Oh, sorry, 100 times 256 divided by 400. And that one was?
64.
Okay, great. Step 3. What color am I missing? Red, blue, green, pink. Chris?
I got for the E1 or expect,
Step 4.
no, the p-value I got 0.0027.
Uh-huh.
And
What's your
that's going to be
step?
less than alpha, and you reject H naught.
Yep, so you reject H naught. Okay, and then, who hasn't spoken in a while? Jason, you just want to bring it home for us?
Enough evidence to reject the claim that there is no difference between in the proportion of people in each economic group who are very happy.
Great. Reject. Claim of no difference in happiness between economic groups. Is that right? Do they call it economic groups? Economic groups. Good? All right. Perfect. Okay. Now, we're going to take a look at ANOVA. It'll take us about 13 minutes, roughly, is my guess. So we should get here quite a bit early. So here's how, this is ANOVA. The very last thing, we're on page 85, I believe, is that right?
86.
86, okay, great. So typically, if we have two means, we use a two-sample t-test. If we have more than two means, 3 or 4 or 5 or more means, we can't use that. Instead, we do what we call ANOVA. It's comparing means to see if they are the same, if they are equal. It is crazy hard to do, so we're just going to do the very basics of it because we're going to let the calculator do basically all the work. They should come from normally distributed populations. They should be independent of each other, and the variances should be roughly equal. Here is our step 1. The mu's are all equal. mu1 equals mu2 equals mu3 equals mu4, however many mu's you have. Okay. Usually only have 3 or 4 means, maybe 5 means, so it's not that bad. Just up to 3 or 4, however many means you got. And then H1 is at least one differs. They don't all have to be different, but at least one of them differs. So what we're looking at is the difference between, if there's no difference between the means, they're all the same, that means that the between group variance should be the same as the within group variance. And we would not reject H naught. But if the between group variance is bigger than the within group variance, then we say the means are not the same. This is what I'm talking about. So imagine you have kindergartners. Their heights are right around here, yes? So this is how much they vary. You have 4th graders. Their heights are right around here, my height, roughly. And then you get high schoolers. Their heights are right around here. So within the groups, their variance is only about this much. But between the groups, there's a really big variance. Does everyone kind of follow? So if the variances, if they're all the same means, then the within the group variance would be the same as between the groups. And this would be about 1. But when the variance between the groups is much bigger than the within the group variance, then this becomes a lot larger than 1. That's when we reject the null hypothesis and say the means are not the same. So the F value is the ratio of the between the group variance compared to the within the group variance. You will have, I'll ask you this question on the exam. All you have to do is I will give you the within group variance and the between group variance and ask you to find the F statistic. You just divide these two. However, I'm going to give you other things to confuse you. I'm going to give you X's and S's and N's and other things just to throw you off. Right? You just have to take, it's the between group variance divided by the within the group variance, because I think it's important to understand that it's how much they vary within the group compared to how much they vary between groups. So that's that ratio. So you will need to know this and use it for your exam. Is that making sense, everybody? Okay, good. Again, they're saying that small p-values, that's when you reject the null hypothesis. So we're going to focus on that instead of the F statistic because I don't want to give you another, table. This would be a lot of tables. We'd have to have a table for T table. We'd have to have a Z table. We'd have to have a PPMC table. We'd have to have a chi-square table. We'd have to have an F statistic table. That's just way too many tables. We use the p-value, which is what everybody in the world pretty much uses nowadays, instead. So what we're going to do is we're going to use the TI 8384, find the p-value. If the p-value is less than or equal to alpha, we'll reject the null hypothesis. If it's bigger than alpha, we will fail to reject the null hypothesis. That's it, straight up. All right, quick comment. We cannot say which mean is different. Just one of them at least is different. Maybe they're all different. But we can't say which one's different, just one of them is different. That's all that we can say with this. So here's an example. I have 3 groups, low blood level, medium blood level, high blood level. So now I know 2 things about each person. I know what group they're in, that's a category, which category they're in, and then I also know a number about them. I know their IQ scores. That's a number. So I know 2 things. One is what category they're in, and 2, I know something numerical about them. So I know one categorical variable and one numerical variable. Everybody kind of good with this? Okay. Good. So we're going to compare this group to that group to this group. We're going to take a look at their means. Here's the first step. So you have to write this down. It's not in your list. So just take it in for now. H naught is I have three different groups. So mu1 equals mu2 equals mu3. H1 would be at least one differs. My alpha, 0.05. And then step 3. So what we're going to do is we would put group 1 into list 1, group 2 into list 2, group 3 into list 3. And then we would do an ANOVA test on those. And we would get a result that looks something like this. This is our TA 84, 85. We would care about the p-value and the F statistic. So those are the two things you need to write down. F stat and the p-value. Here, what's my p-value?
0.019.
Yep. That is less than alpha. So we reject the null hypothesis and say that we have sufficient evidence that the means are different. That, they're not the same. Good? All right, so now we're going to do an example together. This is on page 86,
87.
87, sorry. So a researcher wants to know if there's a difference in the fuel economy for city driving. Tesla claimed that there is no difference, so that's our claim, among the means. Data shown. So here's our data. My H naught is going to be that there's three sections: small, medium, small sedans, small cars, sedans, and luxury vehicles. My H naught is that the first mean equals the second mean equals the third mean. I've got three groups there. And then H1 would be at least one differs. At least one differs. Step 2, alpha, 0.05. Okay, so then, step 3, I need to put this into a calculator. So in bust out the TI 8384, we're going to put this first group into list 1, second group into list 2, last group into list 3. You may need to clear your lists in order to do that. So stat, edit, let me clear my list, clear enter will clear your lists. So go up to you're actually on the L2 or L1 itself, hit clear, which does nothing until you hit enter. Make sure your cursor is actually on the L1, and then type them in. And then double check and make sure that your data is correct. Does everybody have those in yet? Great. So again, double check, make sure your data is correct, because you mess that up and then it's all kinds of trouble. Mine looks good. And then we're going to go to stat, over to test, and arrow up. It's the very bottom one. So hit ANOVA. And now I have to put in, it doesn't know how many lists I have. I have to put in all the lists. I have to type them all in. So L1, so second 1, comma, comma's above the 7, comma, second 2, comma, second 3. Enter. And there we go. There's my S statistic and my p-value. I'll do it one more time. So again, we're going to go to stat, over to test, and arrow up. It's the very bottom one. ANOVA, hit enter. And then I have 3 lists, so I'm going to do second L1, 1 to get L1, comma, second 2 to get L2, and then a comma again is above the 7, second L3. hit enter, and it gives me my F statistic 4.83 and my p-value 0.0375. So my F statistic is 4.83, my p-value is 0.0375. If I had 4 tests, then I'd also have to put L4 in here. Everybody got that? However many tests you have, a list you have. All right, so p-value 0.0375, that is less than alpha. So yes, so I'm going to reject H naught, which means that this one here, enough evidence to reject the claim that the means are the same. You can just leave it like that. Means are the same. Good? All right, that's it.